So this one says, does the equation represent a relation, a function, or both a relation and a function, or neither a relation and a function? Well, I can tell you right now it's a relation because I have y equals, and then on the other side of the equation, I have um, a bunch of x's. So it's definitely, there's a relationship between the value of x and the value of y. In other words, y is dependent upon the value of x. But the easiest way to determine if it's a function is to graph it. So if I go into my graphing calculator and hit y equals and enter in the equation 3x squared minus 9x plus 20 and graph it, I can look at the function and do the vertical line test. But Mr. Adams happens to know that this has a y-intercept at 20. So what I'm going to do before I show the graph, I'm going to go to Window, and I'm going to leave this at negative 10 to 10 on my x minimum and my x maximum, but I'm going to scroll down here to my y minimum and put that at like negative 1, and then my y maximum at 30. And actually, I might go back up here and make my negative 8 for my x minimum and my x maximum 8. So all this does is set up the graph. In other words, my graph is going to have for my x values negative 8 to 8, and then for my y values, my range on the graph, what I see on the calculator, is going to go from negative 1 to 30. So now when I hit graph, I see this is the graph of the function. Now remember that with the horizontal line test, in other words, I've got a graph that kind of, um, this is my graph. It kind of looks like this, okay? The vertical line test is simple, right? If I draw a vertical line and it can only cross the graph one time, then it's a function. In other words, if I draw a vertical line anywhere on this graph and it only crosses one time, then it's a function. So based on that information, the vertical line test tells me that not only is this a function, but it's, or not only is this a relation, but it's a function. Why? It's a function because the vertical line only crosses once. That's it.